So our next presenter, she was here last year talking about the introduction of Isambard. Yeah, you were. You were here last year. I swear you were. Simon was. That's right, Simon. Sorry. Still Isambard, still University of Bristol, but this time it's Sadaf Alam. Thank you. She's going to give an update on where Isambard's at today and some performance, right?
So I will. I think you remember me from Locarno. I was in Locarno.
We have you everywhere.
Okay, now that sounds like even more strange. No, I was in Locarno, and thanks for inviting me. And Paul is always a tough act to follow. So hopefully between coffee and this week, I can share something interesting. So I would like to thank the team, because as we will talk about what has been done, it has been done in a rather record time. Thanks. Can everyone hear me? Sorry, I was just walking behind. Yeah. Because the way things are funded in the UK, and I will just stop here. But there is a really committed team. And I don't know, we couldn't grow people in 3 to 6 months, so Paul, we had to hire them. So we were fortunate enough to get really a great team together and working with, of course, our partners. So this is behind the scene picture back in March for the data center being delivered. So I will talk about, because I was invited last and I couldn't come due to, an accident. And so I will tell what happened since the last one. And I will talk about the project that Paul mentioned, because I thought there will be a lot of talk about TINs and things like that. I will talk a little bit, but not a whole lot. And then I will talk about user and usage experience, because I think that is to me, is the metric of success, whether what we are building is actually delivering value in a reasonable way. And how do I say, rather shamelessly, I'm inviting myself to it's the 7th one. I can't count. I think I had the 7th and 7th and the 8th one. Okay, please invite me. So since the last meeting, we for Isambard, the phase 1 system, so the first full one is not there, but somehow it managed to be on the top on the green. So I said I'll just brag a little bit. So I will say a little bit about University of Bristol. Come and visit us. It's a nice place, I think. And the background to Isambard goes a long way. So Simon McIntosh-Smith, who gave the last talk, and if you are really waiting for the photos of the site, I don't have them in my presentation. So you have to, I think Simon sent me one, but this morning, so I couldn't include it in here. So if you're really keen to see the latest site picture, come and talk to me separately. I didn't include it. So the project was funded, interestingly enough, to investigate the ARM-based processor for HPC in a cluster configuration almost, I would say, 8-9 years ago, as a GW4 project, which is the 4 university, Bath, Bristol, Cardiff, and Exeter. And so Paul talked about the history, and I come from different supercomputing centers that have been around for a long time. The Bristol Center of Supercomputing was formed after the Isambard AI funding, which was about a month ago. So brand new. I think they're still figuring things out organizationally. So now the logo you see up there, and if I can go back a little bit. Yeah, so it was approved almost like 3-4 days ago. And so this is the drawing that will go, I think it will probably is outside the modular data center, because inside the modular data center, there's just no space. So it's not like, Swiss National Supercomputing or other center there. So going quickly, what happened since the last AI, like since in a year? So this is I think the announcement I found dated November 1st, and I think that's went together. Isambard announcement came a little bit earlier, but I wanted to reference the AI research resource announcement, the first, let's not talk about anything else. And that was kind of, this was made that there will be these services provided together for the AI community doing research in the UK. The think I was really, I should not say surprised, but I really admire in the sense. And this is the article that came out maybe December, January last year, where the UK AI Safety Institute, so this is a copy paste from the article. I think it really exemplifies, okay, you are building a system, but you are building a system for a purpose. And it doesn't mean that it is only going to be used for the AI Safety Institute, but if you go and read that article, and by the way, the government has changed, so you will see a banner that this is the previous government initiative. They mention Isambard AI system and the AI Safety Institute together in the same article. After that, we had to take some initiative to start doing the co-design together, because when we asked the government, they say how we should work with each other, they were kind of a bit confused. So we started approaching them. So since almost 3-4 months ago, or maybe, yeah, we have been working in a co-design manner with the AI Safety Institute. So they are setting up the research, their research agenda. We are not doing any AI safety research. However, what we are doing is we are providing them the infrastructure. So what Paul said is a service-oriented model, so we are providing some services. But because it's a digital research infrastructure, so consider it's like a digital research instrument. You continue calibrating and tuning it based on the science and user needs and the time, over time. So it's not like a fixed thing. And Paul talked about the, energy use emission. The way I look at it, and it was really interesting to go with this procurement as part of University of Bristol. So University of Bristol, they have a mission going, they say net zero 2030. We can read into a lot of things, but when we wrote the procurement in like a week time, it was all madness and craziness. Even in that procurement, there was a lot of information asked about the energy use, energy efficiency, and also greenhouse gas emissions, which the vendors were able to provide scope 1, scope 2, scope 3. So starting from the modular data center, the very first part is a very highly energy efficient technology in the sense that you build what you need. And these are designed typically for the 10 to 15 year lifetime. But for the most part, over 95% will be reused or recycled or repurposed. So you just don't throw away. I won't say throw away. So the reuse and recycling rate is very high. Of course, the type of compute you choose is kind of very important. So ARM and GPU, and you can look up what are the power and cooling efficiencies coming, energy or performance efficiency coming by having the single chip in there. Another interesting thing, so we didn't go Paul way, we chose like an elite system in terms of Cray or Cray HPEX, which packs a lot of GPUs. So I think the cabinet in Europe is about 350 kilowatt. In the US, you can go up to 400 kilowatt. And you have a lot of GPUs, a lot of cooling power efficiency, but it's also all in like a closed loop. So the water, the way cooling is done, usually in Bristol, we will largely use free air cooling for the weather condition. And so we are going to get, like our PUE is around 1.05, could be lower depending on how things are being operated. And we have the actual measured value for scope 1, scope 2, and scope 3 emissions. If you want to know the detail, talk to me separately. Yeah, this is what I think. On Mark's request. So when we were building this thing, and people say, oh, you are building an AI system, and especially, I love dearly my NVIDIA colleagues, and you look away if you don't want to look here now. They say it is a GGX system is an AI system, or a very dense 8-node system is the system. The position we took was the system should be, of course, very powerful system for AI, but not just. And over the lifetime, as we are designing is as a digital research instrument or infrastructure, we should be able to tune and calibrate it. So it should not be, I don't want to call it like a one-trick pony type of thing. But there was more to it. So we looked at it in 4 areas. UK is not, the space is limited in the UK, and it was rather quite limited for us in our parking lot. So when we just looked at in the space perspective, So all these GPUs, around 5,500, they are going into 12 HPEEX cabinets. They are a bit wider, but not by a lot. And if we look at getting the same number of GPUs in a DGX configuration, we will be needing about, a lot more. We looked at power at the same time, and again, I used a very conservative estimate on the DGX side, and it was already quite a lot. The total cost of ownership, again, we thought. The part which is really very powerful, if someone is coming and trying to use like established AI software stacks, of course, DGX is all the way up there, but we have made a lot of improvement. Work needs to continue a little bit. And we can go and talk in it. I'll put a disclaimer that because you can't find these things as a marketing and other things, so all the numbers I put there, I can tell you which public sources, and in some cases, I used ChatGPT to get some numbers out. So it's nothing confidential here. And we wrote the way we went about procuring and designing the system in a Cray user group paper, which we'll be happy to share. Things are happening very fast and quite exciting, but I was telling some people, I feel like there is now a little bit, after Isambard-AI up and running and Isambard-3, I feel a bit. So if you can see the timeline, in some cases it feels slow, but in some other cases it feels quite fast. So starting from Isambard projects, they were going on for a long time. But the UK government, they asked us to write a proposal, and back in August, they say, we really like your proposal, and can you do it, but do it very quick. So in a month, procurement was done, and you see the car park up there, where the data center is going, was still very much a car park. And the reason, I would guess, it was happening because the previous prime minister wanted to have this summit, and all these announcements were leading up to that. So in 3 months, we managed to hire enough, I call it a minimum viable team to run a service to get it started. And in March also, the first board were delivered and installed and up and running in a matter of weeks. And there was a submission for ISC Green 500. And recently, I will talk a little bit about what type of applications are running, but at the RSE Con last month, we ran a course. It was very well attended, and on Isambard-AI. It was like you talk to Isambot. That was good. And despite all these craziness, it was amazing that the Isambard-AI, even for HPE and other sites, it was the first. Because sometimes I feel like it's not like total reckless or impossible, but if someone trusts you to do certain thing and you have resources to do it, you can get things done for the very first time because you are allowed to take calculated risks. So I think I would reiterate, in Switzerland, that was the same thing, and that's why, that's how you become into a leadership position and leadership skill. And as Paul was talking about, this innovation cycle, because innovation really it's about taking risk, not being reckless though. So it was the first deployment and power up in less than 2 weeks, including the data center. So there was no data center before that. It was the first direct liquid cool inside a modular data center that HPE put in this form, because these are really dense systems. Typically, they go into a brick mortar thing. And because of the time thing, this system went together with an air-cooled or a modular data center and system called Isambard-3, and that was the first time. So all of these things could have gone spectacular, like I call it. It could be all a spectacular failure in the first part, but thanks to everyone working together, it didn't. And like I said, I've got to wear a hard hat. Never did it in my career throughout. So what are the highlights? And I'm finishing this part so I can move to the other parts. So what we call technical readiness, because there is no call or process in place. So we said how we can start giving the system in hands of early users so they help us tune, calibrate, and learn from it. And these have to be AI users. So we started something we call like the technical readiness project kind of thing, because UKRI is still working through how they are going to run those calls. And So we have a lot of interest in there, and we were gradually onboarding and running. And these also include AI Safety Institute co-design project. And already we have over 200 users and probably 30 projects already on both Isambard-Al and 3 system, and we train at RICCon. And this is the picture and I think Paul alluded to in his slides a little bit. If you go to Isambard-Al page, which is docs.isambard.ac.uk, you will see, for the most part, now it includes a little bit Isambard 3 material. This is what people are looking and asking. They say, how can I get these things? And we tell people where they can just pull a container and run it, where they may want to try doing things via Conda. And as you can see, the classic HPC, I'm a classic HPC person, you do not see those environments and those examples. It's been quite successful. So I'll spend maybe 5 to 6 minutes about talking about this usability or accessibility part, which we are doing together with Cambridge and other partners funded by, So the important thing there was we said, what are we trying to enable? So we wrote a user in a story, long story short, it is about having a Google Colab experience, like a single sign-on Jupyter Notebook type of environment for running AI. So this is the design, and it worked. So with some effort, and in the background, maybe some sticky tape and Band-Aid, but from a user point of view, they think for them, the user experience and story works. So this is the Isambard tutorial that was run a month ago. And this is kind of an important thing. I will stop maybe a minute here. Because when you start explaining people, you can have single sign-on and people can use federated identity, the first reaction you can get from people, oh, it will not be secure. Things will break and other things. So we spend a lot of time, again, with the university and other, how can we design a security architecture that would work with that? So we have a paper, we will be presenting it at an SC24 workshop, but this is like a high-level view of zoning and controlling the access model into the machine. And you can say so you started doing a federated identity provider, did it work? And of course, these are early days, past 4 or 5 months, but what we already see is over 70% of our users, we do not provide them an identity. They come there with their institutional identities. There are few people from industry and other partners we are working through. And because ideally, as a service provider, I should not be, in theory, identity provider. Briefly about who is using it and what they are doing, and this is our help desk part of thing. So this work was presented back in August by Christopher. So this is like a form to get started, applying for the to these 8-week project on time. It's quite detailed, but it kind of helps us understanding. And I think we have now 38 or 37 form, a little bit more than that. So these are the type of applications. And you can see these are, so we picked up that are largely focused on AI. So these are the ones that are already running or gone through the system. So you can see there are different applications of LLMs. So the one I liked it, LLMs for language for Brit-ALs. It's called Brit-LLM. And then you can see reducing computation time and large language model sizes because you want to do things efficiently. And then you have quantifying uncertainty and detecting and correcting hallucination, data poisoning. So it's like a really wide, and there are AI for science type of cases that is typically the first one there. So these are a variety of applications. This is kind of another mapping, more in a storytelling way. So you can see things kind of map from food security to health sciences to conservation. And most of the time, people are either working through Jupyter Notebook or they bring some sort of container. PyTorch is widely used, but not only. There is TensorFlow a little bit doing. Some people, I think 2 projects are largely focusing on AlphaFold. So again, I'm not going to say this is a conclusive list of things. This is like the past 3-4 months experience. Some results, again, early data, I don't want to kind of bring it up. It goes back to this whole, whether to DGX use it or not use it. And this is not a fair comparison. So the example data is picked up from the MLPerf results website, and this is the ResNet. So the reason I wanted to show it, on the other, what you see is what a single node looks like. It's a very powerful node. So it's not like DGX, you can call it almost half a DGX because it has 4 CPUs and 4 Grace Hopper chips essentially that are connected with 4 network cards. So you need to do a lot of performance and tuning, and what you call feed containers are first-class citizens. Majority of the time, we not only have to tune and perform for affinity and binding, but we need to make sure it understands it from running a container, which is non-trivial. So what is happening next? And I have 5 minutes. I started a bit late, so maybe I can say. So this site up and running, already onboarding process. In our earlier plan, the phase 2 of Isambard-Al should have been done in fall this year. And there is a bit of delay, which I can explain on the next slide. But it will be a very potent system. For me, the most funny thing is when people come to Isambard-Al phase 1, they already think the phase 2 is there. They say, why I'm not getting my GPUs? I say, you do not have the full system. It's only a very small system. So it's now about expectation management. Okay, the full system is not there yet. And but from a user point of view, the environment move will be transparent completely. We really want to just not have any user experience change going from a small. It should just scale. So the reason for the delay is there was when funny situations like insurance and other things come up. They wanted a lot more physical security around the parking lot and compound, because Simon and I, we were like, oh, yeah, we will build the system. I come from Switzerland, so to me, like, how any bad thing could even happen? And they say, no. If you want to insure something that costs that much, you need a lot. So this is like a design. You can see there are trees and multiple layering and covering. And so for physical security reasons, that added more requirements going around the pod, around the campus, and other thing. And the other side that is getting almost 5 megawatt of power through these transformers through national grid is how do I say? It's not as efficient as I was expecting. So the hardware, the good thing is all the Isambard-Al phase 2 system is physically in a storage room in UK. We are just waiting for site to be completed to deliver it, which should be early next year. And what you can do there, so this is like an example, I think my colleague Christopher, he would use it. So just think if you are coming from a very, very powerful laptop, you will get an order of magnitude increase on Isambard-Al. So think big. And I think Paul and other people already, like Mark also alluded in his slide. For me, I'm personally very excited about AI for science opportunities. Of course, there will be some great work that will be done for large language model and other things. And the reason is, I looked up some, so this is a Nature research paper. It's a very dense paper. It has done a survey of AI going in science going back like past 4 or 5 years. And I just identified, so AI is used in each and every part of a scientific discovery process. AI-aided data collection, learning representation from data, hypothesis, and then experiment-driven simulation, and I think we learn it. However, at the same time, it's a new tool, it's a new capability coming from a computer science community. So there needs to be a better understanding, and then needs to be additional resources, which Isambard-Al provides. So the compute resource alone is not the solution. There needs to be a lot of investment that goes into the innovation cycle. I think Paul and Mark mentioned already. How do you how you train people to run these experiments in the correct way? every time I give this talk, people are like, how can I access the system? I was like, oh my God. So, and I put this thing because I think last week was a special week. Also for the UK. I think UK did very well for Nobel Prize and of course for AI. So we would like to make sure that, the resources, the discovery process and innovation is kind of there. So I'm sorry to say the call was supposed to probably come out sooner, but it is still in planning, maybe change of government, change of hearts or planning. So there isn't anything out there that I can point to. What I could say is that if you want to still try a technical readiness project, now we have an inquiries mailbox. Please send us an email and then we can, the link to the form was already there, but we can already, point you to that direction. So with that, I can, thanks for the invite. And I didn't introduce myself. So. I'll blame Paul because he kept calling Sadaf. So yeah, I'm Sadaf Alam.
Thank you, Sadaf. We have time for a quick question. Yes, sir.
I have too many questions to ask all of them.
Okay, I'm here until
just one. So the Grace Hopper is obviously a CPU plus GPU. So for me, the main question in my mind is how am I going to use that platform or that design efficiently? Because I just imagine if it's AI, it would just have been GPUs, pure GPUs. So and you had to rush to order the system, so I understand all the difficulties, but what would be the main pros and cons that you can envisage from the GH design?
Okay. No, that is a very good, very fair and very loaded question. Thanks for asking. So the first issue we ran into, even going on NVIDIA side, was having containers available for ARC64 with GPUs. So that was the first thing we ran into. Now its situation is getting better. Same for AlphaFold and other things. So you just, most people who just want to grab a container and run it or have build it in Conda. So yeah, getting an application that you can run is the first hurdle. So you can't take it for granted that it will be there and it will work on an ARC architecture. The second thing is, how am I going to use it efficiently is probably, how long is a piece of thread kind of thing. So we have done, if you saw on my slide, there was a lot of tuning and control because Grace has 72 cores and this processor is locked. So the strategy you will use, so we are now publishing some best practices, but this is just a start. So there are a lot of tuning optimization opportunities up there. However, for the most part, getting things out of the box and running is not an issue, but running it efficiently compared to your x86 dense GPU server or a box, the mileage, I would say, would vary, and it will really be very application specific. So that's the kind of a very generic answer I can give, but I can point to some really horror stories we run along the way.
Thank you for the question. Thank you, Sadaf.
Thank you.